Today we're going to look at some more on shaders in Unity, but I thought it might be good if we looked at how the geometry was actually created, and have a look at the pipeline through to the shaders in a little bit more detail. So with that in mind, let's have a look at what we get out of the box with Unity. That's my video recording stuff where it stops being silly. So this is just a regular scene in Unity. I've got a camera, directional light. Ignore these for now, I'll show you those in a minute. So when we have, if we create any geometry in the scene, so we'll go with a regular cube. So as we described in the other talk, all our geometry, even sprites, are all made up from vertices. But there's other data in that. There's the position themselves, so the vertex position of each of these points on the corners of our cube. There's also the UV, the texture map data, so how do we render the textures on there, and also there's a thing called normals. There's other data there as well as tangents, binormals and other things, but what we're really going to look at today is the UVs, the positions, and the normals. Normals, if you don't know what they are just a way of representing a direction of facing, so which direction that particular point is pointing. All these are flat faces, so we haven't got, they're all quite obvious really. Really not liking recording software. There's something playing up. Hopefully we don't get too many more glitches. Where was I? Yeah, so a normal is effectively the direction the point is facing. So for each one of these faces, so we'll have 1, 2, 3, 4 vertices for that face, but also there'll be 1, 2, 3, 4 vertices for this face, 4 vertices for this face, 1, 2, 3, 4. That means that point is actually 1, 2, 3 points that are there, and each one of them will have, I say that it's possible, but that's the way it's structured. It's possible that there'll be 3 points. It could be 1. We can probably have a look at that later on if we get a chance. But in the cube, in the basic cube you get with Unity, that's going to be 3 points there. So the first structure that goes through the pipeline will have that point position there. It's UV data, and also it's normal. And for the point for this face here, it's going to be pointing literally along that blue line, handily, the direction. Yeah. So the normal is, it will tell the shader that face is facing that way, and that's important when we're actually writing lighting effects. So then if we know the direction of facing just by using the normal, we know how the light can then bounce off those objects. So we also get in the regular cube object that gets created by Unity, there's a few things in there. We've got a cube mesh filter, and effectively that is storing the mesh data. So that's got the mesh in it itself. So that's got all the vertices, the UVs, and the normals, and all the other data that's needed to render the cube. So, but we could change that. I know we just created a cube, but we could literally pick any of the shapes, and that's using a capsule, a cylinder, a plane, a sphere, back to a quad, a cube. So we'll stick with cube. So effectively that's the actual mesh that we're attempting to render. We're also getting a box collider, won't look at those today, and a mesh renderer. Now this is where we can set up the material that the particular mesh is going to use, and we can set up whether the cast shadows are on, and so that means it will be pointing to the Unity cues for casting shadows and receiving shadows. You can apply more than one shade material to the object. Again, we won't look at that today. We can use light probes, we won't look at that again today, but they're quite cool, and also reflection probes and everything else. But all we really need to know about is that we've got our material in there at the moment. It's using the default material. So let's say let's say Unity didn't give us a cube out the box. What happens if we'd had to create our own geometry on the CPU first? I know This probably doesn't sound particularly useful, but it is useful to understand these concepts when you start looking at geometry shaders, and also if say you're going to create a voxel engine, you'll need to understand how to build geometry in another way other than using a modelling tool to be able to write the framework to render that. So that's where I've created these. I've created a class called GeomBuilder, and we've got a mesh render, mesh filter. We could also obviously have a collider on there as well, but at the moment all we need is the filter. You can see we've got it set to none, so it's not got anything to render. And again, I'm just using the default material for now for this example. But in my script I can choose what geometry I want to render. So we'll go with a quad at the moment because that's the most simplest to explain. And if I run that now, he says hopefully, oh, have I commented it out? Or is it the same place as my camera? Oh no, need to kind of switch the thing on, don't you? Be useful, because I'd switched it off. So in the game, so there we have. And I've got the same for my main camera. I've got the same script that I used in the last one for tazzing round, which is just that simple script there. So that's my script has now just generated that quad. And so let's have a look at the code that's actually doing that. If I can find the GeomBuilder, that's it. So we need to set up an array of vertices, which are vector 3s, so the positions. We need to set up an array of indexes, and we need indexes to describe the draw order of each of the triangles. So that's why we've got 1, 2, 3, 4 points, but we've actually got 6 indices, because obviously you want to draw 2 triangles to make a quad. And then for the UVs we've got 1, 2, 3, 4, so that's representing the UV map for a quad. And then I've got normals. The normals for this are quite simple to calculate. It's always going to be facing backwards, so effectively towards the camera. So that was pretty easy to set up. So back to the quads and why they're the indexes and why they're important. If you remember, we just spoke about culling, so back and front face and culling off. If your culling's off, then the indexes really don't matter that much, but you still kind of need to tell it with index primitives how to draw the triangles you want to draw. So if we've got front face culling on and we render the quads in a certain order, it'll see them as being, you can get, it's quite hard to describe actually without actually showing you. So if we flip them, the order of these, you draw the triangles the opposite way around. That way around they'll draw this way around, facing the camera. If we flip them, then and you've cullings on, then you'd be looking at the wrong side of the triangle effectively. Now that order will change depending on whether your graphic system is left or right-handed. I have to think now. I think Unity's left-handed. X and A used to be right-handed, so whenever I was bringing X and A shaders over into Unity, it was always a bit of a pain because the calculations they're the same calcs effectively, but you have to do them the other way around effectively. But anyway, the important thing is we've got these vertices, 1, 2, 3, 4 of them. We can draw them in the right order. We've got UV values for them and normals. So how do we then push that information into our mesh? So I've got build quad. So all I'm going to do is, actually if we go to start, so on start what I do is if I've set this up so that if you do change the type, it'll regenerate the mesh geometry for us. So I call build mesh, which effectively is just going to check the geom type. We've set it to quad, so it's going to call build quad. But before it does any of that, it gets the mesh, creates an instance of mesh, and then what it does, once it's built the geometry it needs to build, it then just gets the mesh filter and sets the shared mesh equal to mesh. You can change that to mesh, but you'll get errors in Unity. Well, not errors, they're kind of like little warnings in Unity saying that the mesh leaks, so you get memory leaks and stuff. So I'll stick with shared mesh. I don't really know the actual difference between mesh and shared mesh. I imagine that the shared mesh is then accessible to other elements in the object stack. So because I'm using the shared mesh on this, I think then the mesh renderer is able to get at that mesh to render the geometry. Maybe wrong, might be worth me googling it. But in any case, so we set the shared mesh to the mesh we want to render. In this case it's a quad, and literally all we're going to do is pack in to the mesh the vertices, which are the 4 that we've set up, the triangles, which are actually the indexes. I don't know why they called them triangles in that. I guess you need them to draw the triangles, but yeah. But when I first started playing with the mesh object, it was a bit of it threw me a bit, because I always see them as indexes, and then we've got the UV, and basically that's it. Pretty much loaded it up, and that's it. That's how it's going to generate the geometry on the fly, pretty much. So we've got other mappings for a cube. Obviously there's 6 faces, so that's 1, 2, 3, 4, 5, 6 faces, and then we're going to have 6 lots of indexes to draw those 6 faces. We need then 6 lots of UVs and 6 lots of normals. When you come to spheres, they are at the spheres. What I did to get all these positional data was to basically render the Unity geometry, and I just nicked all the vertex, index, UV and normal data out of it, just wrote it to a file so I could then reproduce it here. But this shows you that we can produce that exact same geometry. But look, it's massive, it's huge. Yes, there's quite a bit in spheres. Plane verts, that's pretty much the same as it's like multiple quads effectively, but all bound together through the indexes. Same with the UVs, normals, and then a cylinder. All that positional data build a cylinder, capsules, and I've added one just to show that you can create your own geometry. A triangle, so that will just give us a triangle. So we've got 1, 2, 3 points. The 3 we want to draw, and the triangle, UV, and normals. So let's have a look at rendering some of those. So we've got it as a regular quad again, but if we change that to cube, and as you can see, there's no, the mesh filter is empty. On an actual cube, you could see that it was a cube in there. We could probably pick and change, but it's not going to show what we've got selected because you've got nothing that's from the regular pool of Unity geometry. So now we'll flip it over to a sphere. As you can see, they're pretty much, well, they are the same because I've stole all the geometry from the base objects. And a plane, and then a cylinder, and a capsule, and then my triangle. So, like so. So you can see you could probably then create another one, pyramid maybe, or diamond, or whatever, and so you can create whatever geometry you like. Obviously I wouldn't recommend doing this for your game assets. You'd want to use something like Blender or whatever your preferred modelling tool is. But if you want to create geometry on the fly for things like voxel engines and that sort of stuff, then you're going to need to know how to build this geometry. So if we go back, let's go stick to a cube. What I'll do is I'll drop a cube in the scene as well, so we can compare what's going on. Is it 0, -10, 0? I'm going to put that to 2. So if I set that to cube, which is 1 again. So now we've got my generating code cube and Unity's cube. We can change Unity's cube to sphere, mine to, oh no, I don't need to change that, do I? Silly me. To sphere, so you can see they're pretty much rendering the same geometry. So how does all this affect our shader? I hear you screaming to ask and no. Let's go back to cube. Well, let's have a look at that. So if we set these to use, so their default material, so I'll use it to use, I think, my test material. Oh, I got rid of the shader, didn't I? Right, let's set up, I'm going to change my test to use just the regular standard opaque. Oh, good, it's picked it up. So it's got that texture, and so we can get object base, and we'll set it to use the same shader as well. So you can see. So using the normals, it's able to shade. You can see, you know, this side of the box is darker than that side because the directional light is pointing, you know, in that direction. So that side's effectively shaded more than this side is, and the top's quite bright as well. Excuse me. And also all the texture, the UV texture data is getting in there because it knows then how to and where to render that texture. So what happens if we start manipulating these? Let me put the shaders to. If we start manipulating these, so I've created a texture rotate. So what it will do is it will rotate the texture around the mesh. So let's have a look at the texture rotation shader. So it's got all I did was take like a regular stock shader. So, you know, right click, create shader, surface shader. So we don't have to worry about writing the vertices to the graphics card. It's all part of the intrinsic Unity shaders will do that for us. All this is the standard stuff. All I've really added is a rotation speed, a bounce frequency, and an amplitude. So the rotation speed is how quickly it's going to rotate around the mesh. The bounce frequency is how often it's going to go up and down, and the amplitude is how far it's going to go up and down. And again, we've got this targeting shader 3, which is all part of the standard when you create a new shader, surface shader, glossiness, colour. So I've added my 3 new variables there, and all I've done is add this line to the shader, which is effectively, well, these 2 lines, I guess. So I'm recording the UV that's getting passed in from the vertex shader, and then I'm going to manipulate that UV, and I'm going to manipulate it on the x-axis and its y-axis. Now the x-axis is going to be how fast it rotates around the mesh over time, and the y-axis is going to be the bounce, so how we're going to move it up and the texture up and down on the mesh. Now this, you'll look, there's like the sine wave is very, very similar to if you remember the water shader I did, where we were actually altering the geometry, but we're only, you know, so to make that wave effect on the sprite mesh. And it's exactly the same calculation, except rather than us manipulating the geometry itself, when manipulating the texture. Why is that changed? Well, what am I changing there? Nothing. That's all. Oh, because I was messing about with that one. Yeah. So we're changing the UV data, not the mesh positional point data. But it's exactly the same calculation. We're just doing it in a different place. So the surface shader is like your fragment shader, but it's actually called before the fragment stroke pixel shader. So it sets up all the colours and everything to be rendered on the geometry. Then it goes off to the lighting or fragment shader, the light that we can set up. You can create your own, but we're using the regular ones that come with. We're using standard in this case. And then that's used to light it. So all the normals and everything are passed to that, and it does all the lighting for us. So all we're doing is affecting the UV. As I say, we're going to rotate it and move it over time. So if we now apply, so to object base, I'll set that to my texture rotation. I'll do the same with the cube actually. Actually, I'm not running against the cube, but it should behave exactly the same. But what we're going to do, so with our cube, each time one of these UV values comes in, cube UV, so first one's at 0, next one's at right, up and so on. So that's the 4 for the first face, next face, second face, third, fourth, fifth and sixth face. It's going to oscillate and change those values in the shader. So let's have a look at that actually happening. I'll set those shades up. Yeah. Okay, so that's the effect we get. So it's the geometry is not changing, but we're changing at runtime the texture effect. And again, you could mix this in with the altering the vertices, mix it with your water effect. You can use this to do like ripple effects and all sorts of stuff you can use when manipulating the UVs. In fact, I don't know if I did an article on heat haze for Unity3D mag, and in that, basically all I was doing was manipulating the UV values on a quad to make it look like the air was in that area was being affected by the heat. So what we can do is we can play with some of these values now. So we've got smoothness, metallic, rotation speed. You can see actually like metallic and smoothness, they're both on sliders, and that's because in the shader, in the parameters, they're set up as ranges. We could do exactly the same for these actually. Might be better if we do that. I'll show you that in a second, but let's have a look at altering these values. So yeah, so we can change speed up the rotation to 1, so it's bounce factor to 0.5, it's not bouncing as much, water to 2, make that 1, so it's literally going all the way up, all the way down. There's that, so you can literally do anything you like with the to 0, pretty much anything you like with it, and this all apply to whatever the geometry is. So we could flip that over from a cube to a quad. It's doing it on the quad. Excuse me, it's flipped it because the UVs on the quad are different to the cube. This here is the regular Unity stock cube. So the front facing is there for the cube. It's just the way they've created it. So whether it's a quad, whether it's a sphere even, slow that down a bit, it's going too fast now. It's crazy fast. Go 0.25. Yeah, and so and even if we alter the scale of it, so it doesn't matter what we do to that geometry now, that's gonna render the same every time. So it's pretty cool, I think, what you can do with shaders. So let's have a look with plane, which is a bit bigger. It's just like a quad really, but we're still just manipulating the UVs. Cylinder. The cylinder's quite cool, I think, because you get a nice neat wrap all the way around. Ooh, that reminds me, I'll show you now actually while we've got the cylinder up. If your texture that you're using to render is not set with the wrap mode to repeat, what it does is it clips the UV values when they're being used. So what we're doing at the moment is going, so top left hand corner, as you remember, is 0, 0, and let's say we're decrementing that by 0.1 every time, so it goes to minus 0.1, minus 0.2, minus 0.3, minus 0.4. What it does when it's wrapped is, instead of going to minus 0.1 when it goes through the pipeline, it then becomes 0.9. So it wraps, effectively wraps around. Same on the y-axis as well. So then minus, when we take away 0.2, it's then actually 0.8, not minus 0.2. So then your texture effectively, as you can see here, flows. Oops, the wrong thing. Effectively flows all the way around your mesh. In this case, and even on the cube, it's doing it to. It's changing there because the UV values on that face. We could probably fix that in code because now we've got our own version of it. To alter the UVs on that face, so they're flipped. Yeah, so that's why it's wrapping around and not being clipped. What I'll do is I'll change that texture to be clamped and apply, and now it's just gone off. You can't see it at all because the value's gone well below 0. If I start that again from scratch while it's clamped, so what you can see is it's going around and then eventually it's gone. Let me put those back to cylinders because it's easier to see it happen. So yeah, see, you can see, oh, it's gone. Yeah, so you can see it's wrapping around. It's not wrapping around. So you've got to make sure that if you're going to use UVs to wrap and go outside the bounds of 0 and 1 in the UV map, then you need to have your texture mode wrapped. Yeah, so as I say, pretty much any geometry now we can play that against. So you've got to apply that to the texture. Cylinder, capsule. What I quite like about the capsule is you get some pinching at the top and bottom when you bounces on, which I thought would look quite cool. So I get 0.5 and I'll get 0.5. That's because it will bounce more. So as it comes around, look, so you get that pinches up. 0.5 is probably too much. Now, you see that little white dot that come up then, just wrap around just enough to. But yeah, so it kind of wraps around the top of the mesh. I quite like that. So with my triangle, what it's going to do is, well, like it is on all the other geometry really. The sphere is quite cool. Yeah, you probably see the pinching better on the sphere actually. Yeah, so as you can imagine, like combine this with manipulating the UVs as well at runtime, you can get some really funky effects going on with your geometry. And as I say, you can apply ripples and God knows whatever else you want to whatever you can imagine, you can literally do with a shader. They're pretty cool. Another thing I wanted to look at was I've created another, so it's kind of like yeah, I'll save it. I've kind of like done like a bit of a mini game, but I didn't really want to do a mini game. I just wanted to be able to apply shaders to some of the new Unity UI elements, and that's kind of what I've done here with these progress bars. When I was starting doing it, I found out that it's not as simple as just writing a regular fragment or surface shader or anything like that. There's a fair bit going on in there. But once you understand what all that base stuff is, 90% of it you're not really going to want to touch anyway. You just want to go in and alter the UV and geometry data really. But I thought I'd show you how to actually go about altering these, because you can get some quite. I mean, the controls are pretty cool anyway, but you can do, you can extend them even more by having even more super duper stuff in there. So basically what I've got is they're effectively progress bars. I'm going to use them for, so when I can move my ships up and down, I've restricted them to, so I don't like a 2-player thing. Only keyboard, I've not gone wild. Yeah, so simply if I hold down my shoot button, I can build up power, and if I hit A, that's gonna, yeah, so I'm not going to hit A while I'm doing that, because that's just sent it bonkers. Right, so if I hold down my shoot button, I can hold it down, and as I build it up, the more power I get, the faster my bullet's going to go. So to there, boof. Right, what I can do now as well is if I line up, actually I'm going to move them both to the bottom, that'd be easier. If I line up, and then if I shoot at that other guy, what you'll see is his health bar will go down when he gets hit. And this is all done through the shader. Not the actual text display percentage, but the colours from one end to the other, and the textures as well, being the way they're rendered there. So basically, I'll pass in a float value from 0 to 1, and that's how it's. I can do it to none. And also, what I found was, if you remember in the first talk as well, I did that flash shader, where when it collides, what did I call it? Flash flashbang or something like that. Anyway, so if you collide, it does that flash on it. If I use the regular shader for the ships, what I found was happening was the culling got, the way it was rendering it, it was almost as if it ignored the UI completely. This background's the stars are UI. So if I use my, that's it, flash matte, just on that one, see it's called it, and that's because my camera color, background color, is a skybox, and so it's as if it's completely ignoring on that render pipeline the UI. But so I've created a new shader effectively in material, which I called surface. Where is it? Surface flash matte. So my surface flash material, and that's basically because it's using, I think, because it's using the surface renderer rather than a regular vertex fragment one, it's getting into the right pipeline, and it didn't matter what I changed, it was an absolute pain in the bum. I don't know why it was doing it, but that's how I worked around it anyway. So, but yeah, so let's have a look at these shaders. And actually, before we look at the shaders, let's look at the objects and how they're constructed. So I've got a regular canvas, and I've got so that's the I've got progress bar for player 1, UI for player 1, and there's a background to that which is just black, and then there's an image value, so which the image is just regular blank image, so there's no image in there. I suppose I could really swap that out for something like white pixel, doesn't really matter. Actually, I've noticed when you're not using, I think it's either raw image or image, if you don't give a texture and then say you had it as a prefab and then included it, pulled it into another scene, it grabs just any old random texture, and I've ended up with a bit of a pain with that. So it's always best to set the textures, don't leave it empty like I just did. That's very annoying. But yeah, so, and I've got my progress bar material, which is using my progress bar shader. I'll show you that in a minute. And I've also got a script to manage that as well. So what we can do is if we run it, I can show you what's actually going on just through the script. So the script on that, so is at value 0 at the moment. If I set it to 5, it's getting set straight back down immediately because of the game script. But you can see it's changing the value directly. So if we watch this value now as I go to shoot, yeah, so it's creeping up, boom, and it shoots. Okay, and then the left to right is basically how it's rendering the texture. So this isn't left to right, so it's right to left. So as it's drawing, oops, wrong button. As it's drawing, it's going from right to left. This one, if we have a look, is left to right. So when this shoots, it goes from left to right. And the same with these two as well. They're using pretty much the same sort of thing. But also you'll notice that one's using progress bar matte 2. That's using progress bar matte. So I'm having to create, even though they're using the same shader, I'm having to create separate materials, because I think what's happening is that when you have a material, if they both use the same material, they're using shared memory to do it, and that just ended up with a really cockeyed render, because you'd set the value on one, and depending on whoever was the last one to be rendered, that was the value that then got set to both of them. So that's why I've got two different materials, but they are using the same shader, which I think I am. So I remember I set it up. Yeah, so matte 2 is using progress bar shader, and progress bar matte is using progress bar shader. So that's quite an important thing to remember as well, that your materials do share the same memory. So if you need to do something like this, you need to split create a separate material for it. And the hits progress bar, pretty much the same mechanic. So we've got an image value, and so we're using progress bar texture material, because we're doing it through a texture rather than a color. And then instead of giving it a color, as we saw on these, so I can set a progress bar color, it's using a texture to do it. So my health texture is that little texture there. My death texture is the base texture, which is death texture there, which if we have a look, is that one, and then my health texture there. So let's have a look at the scripts now and see what they're doing. So on the color progress scripts, should be the same script for that. Yeah, color progress. And again, like before with the flash one, we grab the material in the start. I grabbed the raw image because I was going to use the image material straight off the bat, but I thought there's no point, might as well just let it render through. So, but that's why I grabbed the image. I could have just done get component dot material and assigned it straight to map. But anyway, so I've got the material, and then basically in the fixed update, and I do it there because I find that fixed update is literally that. So it's on the step, so you know it's going to be a regular constant. You're just not going to be hanging around. I think the regular updates in some kind of Unity thread, and it'll fire it when it can fire it. Whereas fixed update, you know it's always going to fire on the pulse. So first thing I do is make sure it's clamp the value between 0 and 1, because we don't want to be pushing values outside that range. I think I'll probably clamp it in the shade as well, just to make sure. And then basically I pass in the progress color, the progress value that we've just set, and whether it's left to right or not. And then I just set my text to wherever I want the text to be. And what I do in that is it's passed in. So text is literally that text there, so we know it's the text for this component, and that's pretty much it. So how does that know that to change when player 2 does his thing? So let's have a look at the player script. I've used one script actually for all the ships. So the player script, so that's ship 2. So that's getting the power bar is what is the image value from progress bar 2, and the health bar is the image value from number 2, from the second one as well. Bullet prefab is just a prefab to shoot a bullet. It's literally just a sprite, that's all it is. And then basically starting health, starting power, is it player 1, because I'll show you in the script, because I'm using one script to control both players. If it's player 1, then these are my keys to move them up and down, and that's the key to shoot. Clamping the power again for the shot. If they're releasing the power, then I'll do the shoot. And again, same thing but for different keys. And then what I do is I can set the power bar value. I'll show you the scripts for the power bar value. I just did, didn't I? Yeah, so my power bar value. What am I doing? Yeah, color progress script. Yeah, so all I'm doing is affecting the value that's coming in and the fixed update, making sure it's clamped, and then as I just showed you, it's passing it down to the shader. And then the health bar as well, and then I just make sure it doesn't go off the screen. So I'll just kind of, I suppose I could have clamped the position there, but I am sort of clamping it anyway. And stop it, so I'm using rigid body, killing the velocity as well. And the shoot mechanic is literally just instantiate the bullet prefab. Its position is going to be just in front of my ship, so the transform direction up, so that's going to be in front of my ship. I'm using the vector up because if you look at the ship, that's how it's rendered, but I'm rendering it that way. So effectively it's been rotated round 90 degrees. In fact, actually, yeah, you can see, so it's 90 degrees round on the Z-axis. So that's to it in its own object space, so that's up. So that's why I've set it to up. And then the rotation is just identity, so there's not changing any of the rotation. And then the bullet, I'd set the rigid body on it, the velocity to be whatever the power value is. So I've done max, because if they give it pitiful amount of power, I at least want the bullet to move, so I'll give it at minimum 0.25. And that's going in the direction again of up, so it's transform direction. That's the velocity we apply to it for times 20, just to give it some oomph. And then on collision, I literally just reduce the health by 0.5, which is updated on the fixed update, and then I destroy the bullet as well. Yeah, pretty simple really. And the flash on bash scripts, yeah, that's it, is it's the same flash on bash script as before. It's just grabbing a different material, because the materials have got the same parameters, it all works fine. I'll quickly show you that. So if I remind you, the old flash shader, it was literally just a vertex fragment shader, just to demonstrate the flash. but with the Unity UI, for some reason I had to use a surface shader to do it, and literally I've created my own lighting model to do it because I don't want any lights on it. So instead of putting any lighting calculations in, it's just going to return straight the colour as it is. So there's no lighting done on it at all. And then so then the surface just does what the surface shader is effectively doing, what the flash fragment shader was doing, and then that just stopped the horrible render effect that I was getting. Yeah, so let's look at the texture. No, the color progress bar one first. So this is a vertex fragment shader, and to do it, as I say, I've had to, basically what I did was I downloaded, if you go to Unity, you can download the stock, the custom, all the shaders that come with Unity. So I went in and had a look at the regular UI shader, and basically I've just copied and pasted that, changed the path and the name of it, and then just altered the calculation in the fragment shader. So all this literally from, other than my bits here, those three parameters there, all the parameters above, the tags, the stencil, all the culling, lighting off, color mask, and the paths, includes these structures, all those right the way down to those three values, all that's theirs, all that's theirs, everything in here is theirs, apart from me manipulating the text chord X value. So what are we actually doing in there? So we're getting the current text chord value of the pixel that we're on. If we're going left to right, so if we're not going left to right, we flip it, so we subtract 1 from it, so we want to be going the other way, so that if my value that's been passed in is less than the text coordinate, then we want to change the color from, instead of the background color that's passed in, we want to change it to, the background color that's passed in, not the texture. I'll come to the texture one in a minute. The color that's passed in, then we use my progress bar color, and that's why when we're rendering this, when this gets to 50%, so which is at 0.5, yeah, that's what that is. So as that's going up through the values are going 0.5, it's going all the way up. If we have a look at the ship game controller, the reason why it's going back down, because if I'm not holding it down, I'm subtracting 0.05 from it. So that'll go up, and it'll go up to 1 at the most. When it's at 1, it's at 100%. So if I hold this down now until it gets to 100%, so that's now just at 1, so it's, and then it comes back down. And literally all that is done, the colour change is done in the shader using the UV values. Yeah, so I mean we could, where's the shader, there it is. And that's it, it's really simple really. So all I'm doing is checking which way I want to be going. Once I know I'm less than the value that's passed in, I know I need to change the colour of it. Everything else is back from the stock UI shader. So now as you can see, he's at 50%, so, and he's going left to right. So we're showing half of the So showing half of the regular texture that's part of the raw texture image, and the other half is the hearts, the health texture. That's 2. That's why. So I was wondering why the value is at 1. So why is that at 1? Should be at 0.5. And it's because I'm looking at the wrong one. Back to P1. Yeah, so 0.4999. Yeah, so whatever the value. So that's at 0.5. So that's why we're at 50%. And again, that's done pretty much the same way with texture shader. So again, all ripped from there. Those three parameters are the same. Textures, those three are mine again, but instead of a color we're using a progress texture. Yeah, so we're using the texture instead of a color, and effectively what we're doing is, okay, so we'll load it all with the color that's normally passed in, multiply by wherever the color was set to, which I think is white. You should probably put that apply in colour on this as well. Actually, I don't know what texture sample add is. That's part of the UI base shader that I've took this from. Something I need to Google and look at actually. If I find out what it is, I'll let you guys know. But again, so there's a left to right. It is left to right, so it doesn't need to flip it. If it's less than the value, then I need to replace the colour with my texture, and that's it. It's exactly the same as the colour shader. So that's it. Pretty much all I want to get covered really today. Oh, I've done it again. Pressed A. Yeah, so I hope you found that useful, and might move on to some other shades next. I've been toying with the idea of doing, a friend of mine, you know who you are, come up with the idea of doing, I don't know if you know this, Jim will paint it, and basically you say, oh, I want this painting or drawing or whatever else, and he'll go and he'll draw it and post it, and it's quite a funny site. So my mate came up with the idea, oh, why don't you do a Charles will code it? So I might do that. So what I might do is ask if there's anything, any game mechanic, any shader effects or any other effects, particle effects, geometry shades, compute shaders, any aspects really of game dev and in Unity, or even if it's like if you want to do something in Blender or whatever else, give me a shout, and if I like the idea of it and I think I can do it, I'll do a vlog post on it. Yeah, so I might put a Facebook page up so people can put requests in and stuff, but I'm still really toying with the idea. But if you think it's a good idea, let me know, and I'll probably forward you on with it. Anyway, I hope you all have a good day, and thanks for listening.